Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone please pause the video, read the question carefully and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now look at the question. Comment on the optical activity of the products. They are. Actually this is a ketone and it reacts with this methyl magnesium bromide in obviously anhydrous ether. So you can say it's a Grignard reagent reaction and second step is workup. I shall discuss about it later. It produces product. Actually, it produces two products. So you have to say what is the relationship between them. They are actually what kind of. Four options are given. So in order to understand this question, we need to understand two things. One, reactivity, another thing, stereochemistry. So this problem is a combination of nucleophilic addition as well as stereochemistry. Now if you look at this compound, it has two types of centers. If I say one is this carbonyl group, another this chiral center. This methyl group is top and obviously bottom there is one hydrogen. By the way, this is enantiopure. I mean one enantiomer is taken for this reaction and it will react with this Grignard reagent. Now if I say Grignard reagent, if you look at in this Grignard reagent there is carbon magnesium bond. Because of electronegativity difference, this carbon is delta negative. Actually carbon is slightly more electronegative than magnesium, even bromine also. So that's why this magnesium is delta plus, this is delta minus. Some people give it completely ionic state. I mean carbon minus, magnesium 2 plus, Br minus. If you think like that, your problem will be solved. But I don't think that's a completely accurate, because generally these carbon magnesium bonds is nearly 34% ionic. So I can say it's a polar covalent bond. It is not at all ionic. It's not closer to 80% or 100%. That's how we can say it's ionic. So it's a polar covalent bond. Now, if you look at polar covalent bond, this carbon is carrying delta negative, and that is the reason it can act as base or nucleophile wherever it needed. And this bromine also carrying delta negative. Now you may think one question, that's sir, why carbon is nucleophilic? Why not bromine? Because it also has some extra electron density. Remember, this bromine is slightly more electronegative element. Why? Because it's a group 17 halogen. Now more electronegative atom carrying some extra electron density. Negative, delta negative means extra electron. So it should be slightly more stable. So if it is more stable, can I say this side is less reactive? So this side will not react. Now who can act as nucleophile? Obviously this methyl. Now why? Because remember, carbon is neither electronegative atom nor electropositive atom. So its electronegativity is exactly in between. So this slight extra electron density on this carbon atom makes it more reactive or more nucleophilic in this case. Now if you look at here, this is carbonyl group. So this is delta positive, this is delta negative. Now what can happen? This methyl group can do a nucleophilic addition. But since I am talking about stereochemistry, so I shall discuss little bit about the way of nucleophilic addition. Now if you look at here, this is actually a pi bond. Pi bond means you can say it's a sigma plus pi bond. Actually it's a double bond. I should say it's a combination of sigma and pi bond, and we know pi bonds are slightly weaker compared to sigma bond. If I draw this carbonyl group, so this is carbon oxygen sigma. Remember, sigma bond is far more stronger because the electron density is exactly in between the two nucleus. So the electron density is strongly held by both of the nucleus. So it's a stronger bond. But the pi bond is made by the overlap of these two p orbital parallel or sidewise manner. Agree. Now here this carbon is delta positive. So you can say this is electron deficient. So that's why this methyl, which is acting as nucleophile here, will attack. Now there is an interesting point. So if you look at this carbonyl group, this carbon is sp2 hybridized and it is planar. So, and in this case, remember student, one term, it is named as Bürgi-Dunitz, or some people say Bürgi-Dunitz trajectory. So it is actually a phenomena which explains that way of nucleophilic attack. I mean, this nucleophile prefers to attack in this direction, in this nearly 107-degree angle. I know will be confused, sir, it's a new concept. Yes, that's why I suggest everyone please read this concept. This may be helpful to you. So now nucleophile can attack in this way, because I'm telling it's a sp2 planar. So above the plane, this 107-degree angle with the plane here. Similarly, you can think in a different way also. You can think, okay sir, this angle nucleophilic attack also possible. Yes, It is also nearly, I repeat the word, nearly 107. So nucleophile can attack both of the angle, or easily if I explain, there is one p orbital, and this p orbital has two lobes. So nucleophile can attack on the top lobe one side, bottom lobe another side, and both have equal probability. So nucleophile can attack both of the lobes with equal probability. Just imagine if the nucleophile attacks, I mean nucleophile means this methyl group attacks from the top lobe, it will result this one, because after nucleophilic attack this pi bond will be opened up. Agree? So it's O minus methyl top, and if this attacks from the bottom side, then you can expect methyl group bottom, oxygen is O minus. By the way, look at this stereo center or chiral center is same, it is not affected. So both have 50-50 chance. So 50% will be produced this one, 50% will be produced this one. Now let's come to this ammonium chloride. Actually student, this is used as workup reagent. Now you can ask me that, sir, you could have been written dilute HCl or dilute sulfuric acid, like that. Why you have written ammonium chloride? Remember, dilute HCl or dilute sulfuric acid, they are also stronger acid. So in presence of them, these O minus will be protonated, but reaction will not stop here. What will happen? So these will protonate further. Ultimately it will generate a carbocation. I am saying carbocation is also a planar species, sp2 hybridized. So again after that there could be elimination. So lots of things possible, but since my question is about the stereochemistry, so that's why a very careful reagent needed. What do I mean? This aqueous ammonium chloride means actually ammonium chloride is made of strong acid, weak base. So in presence of water it undergo hydrolysis, means breakage by water. So what it produces? It produces weak alkali like ammonium hydroxide along with strong acid HCl. These HCl completely ionizes into H plus and Cl minus. However, this ammonium chloride is partially ionizes to ammonium plus and HO minus. So in the reaction medium there is slight excess of H plus, results a weakly acidic medium. And obviously we also need this because there is O minus, so I need to quench it, convert it to OH, so I need a weakly acidic medium. Not only that, my pH or my acidity will be very weak such that further protonation and carbocation formation cannot take place. So I need to keep this thing in mind. So that's why this aqueous ammonium chloride is used. So to student, it's a very important concept. Remember, it provides the moderate pH such that this produced tertiary alcohol cannot undergo protonation and subsequently water elimination to produce tertiary butyl carbocation, because tertiary carbocations have significant stabilization. Now, so in this way both of the product will produce, and if you look at this product, they are diastereomers with each other. So if you look at this chiral center, they are actually mirror image, you may think like that, but if you look at this chiral center, so this is same, these two are same. So what is diastereomer? Diastereomer is actually in this case two molecules which are stereoisomer. Okay, they have same molecular formula, same connectivity and different arrangement of atoms or bond in three-dimensional space, but they are not even enantiomer also, means they are not mirror image to each other. Now, actually enantiomer, if you look at, they are mirror image, they are non-superimposable, but in this case they are not mirror image but they are non-superimposable also. This thing is observed in this case and they are produced 1:1 mixture. So this combination, their relationship is actually diastereomeric to each other. Agree? Now some people may say one thing, that sir, this methyl group have significant bulkness, so will be the ratio exactly 1:1? Answer is no. But your understanding purpose, I have explained, one will be slightly excess, another will be slightly less, but doesn't it matter? What is the relationship between them? They are diastereomeric to each other. That's my question. So in this case, it will be the diastereomer. Option B is the right answer. Now, if you get this question in your exam hall, how can you solve it less than 30 seconds? For that purpose, you need to look at the question carefully. What kind of reaction it is asked? It is a carbonyl addition to ketone. It will result a tertiary alcohol. And remember this information: aqueous ammonium chloride result weakly acidic medium, which results actually work up to get tertiary alcohol. This is a method to get tertiary alcohol without carbocation formation. Now, if you think, okay, if you, in this case, student, you need to understand that p orbital, both lobe, nucleophilic addition will have same probability. And if you can remember the Bürgi-Dunitz directory concept, it's a very good, you know the exact thing. Now, racemic mixture here not possible because this center is not going to change. Completely not mirror image to each other. Gone. Optically inactive? No. Since it is same, how can it be optically inactive? Not possible. This is. And so option mesoprom, it's not at all. So it is a diastereomer. And in this case, student, I'll not say it's very easy. You have to study, you have to remember something, and you have to practice more. Then only you can solve it very quick. Okay, so this is the overall discussion. I believe you have learned a lot. And if you really consider the content of my channel is worthy, then please help this channel to grow. And regarding the logo of my channel, please read this part. Your doubt will be clear. So see you in my next video. Bye bye.